you, John. Not sure if the microphone is working or not, but thank you, John, again for the and all the previous speakers for excellent presentations this morning. Like, I hope we can match now the quality of presentations and the level of interest. But anyhow, this is update number 7. As you can see, we have done for the people in the audience that are not aware of the pilot project. We have been working since January on this project, so feel free to go online and check all the presentations. We have all the videos and PDFs there. So today what we're talking about, well, of course, as we all know, is prefabrication. And I'll be doing a 5-minute introduction, and then there'll be presentations. Paul Sexton is going to speak on behalf of Nugent Manufacturing, and Keith as well is going to speak, about their involvement on the project. We kept this presentation very short. I managed to keep it under 100 slides. So hopefully, but hold on to your seats, because look, if you miss one, we have quite a few per minute, So what have we been doing over the last few months? Well, I think we all deserved a good break, for a few months. We just completely ignored the pilot project, and we were involved in some kind of a beach interaction modeling on the beach. So, and some of us then, checked also, small scale simulation of extreme coastal erosion. It's quite interesting. I think we should have used actually prefabrication elements, so that it would withstand the forces of nature a bit better. But look, what is prefabrication? We have quite a few different types. You have total building prefabrication, modular systems that architects seem to like a lot as well, and you have elemental prefabrication. And what about the experience? Do we have, as architects or engineers, the necessary experience, or even the general professions? If you go back in history, you can find, references even in the Bible about prefabrication. For instance, the Temple of Solomon, was prefabricated apparently, in major sections. And it's only a few years later that, Langs, a few years, a few hundred years, Philip Gagan was employed at Langs in the UK. That in post-war period, they were doing a lot of prefabrication to, satisfy the demands of the lack of housing. So he gave us quite a good insight into the prefabrication aspects on pilot projects. And his designs were quite, heavily influenced by Harbroken's flexible design concept, which means, look, very often we have a notion of prefabrication gives you a very kind of strict adherence to certain rules and certain limitations of architectural designs, but it's still possible if you have an open mind. So we also were involved with ICON in a prefabrication project in Glencree, the Centre for Reconciliation. That was in 2006. So we did a full BIM model for that. And also in our practice, we deal with prefabrication all the time with timber frame constructions. So this was actually 3D DWG. So we're hoping now that more companies are going to move towards the IFC platform or any other platform that we can integrate. So the pilot projects, what type of prefabrication are we talking about? Total, building prefabrication wouldn't really be, suitable. But it does exist. You can see here the micro complex home, which is fantastic. Just builds within a factory, pre-finished, and just craned into place, with a small scale, of course. We also have very interesting examples of modular prefabrication, all the way back to the 50s. And also here, Citizen M, I would welcome, I would encourage you to have a look on the internet. It's a modular hotel system where they stack up all the bedrooms and link it up to corridors. And also you have modular prefabrication in relation to, futuristic approach, where they even print and prefabricate the units by extrusion and on-site, just close to the site. We may come there, robotics will improve over time, of course. But in terms of the pilot project, elemental prefabrication is the most relevant. We're talking about slabs, roof panels, stairs, and steel structures. So we had a few workshops online, of course, to see look, which way are we going to go? We had a few sound issues at some point in time, and that's where technology not always works. So at some point we had to resort to sign language, so it doesn't always work, but it was still, we got our ideas across. So we decided to share the model, and, we had a series of IFC files. We combined them all into a Tekla BIM site as a federated BIM model, so we can turn the one off, the one, on and off, and check for clashes as well. It's very easy to use. It's a free app. It looks like we all do a promotional presentation now for TechLab today, but it is a free tool, so I would really encourage everybody to even have a check and see what its capabilities are. So, in here, like you can see, you can embed also comments about, the roof system. We sent to Kingspan, for instance. We were saying that, look, you can use a KS1000 roof panel type, and they came as to us with a very interesting proposal, which we see after. So we saved that federated model as a TechLab BIM site model with all the comments, and then we gave it to Solibri, Nugent Manufacturing as well, of course, and Kingspan. But before going there, since we were not successful in appointing prefabricated concrete manufacturing outfit to look at the concrete elements. As an architect, we're always wondering, could it be done for the wall, the main feature wall in front of the building? So this is just an example of how you could do it. The existing elevation here, the street elevation. This is just a subdivision of the panels, how it could be done. So the initial design for the ones of you that are not really familiar with the project, this is the way it looks. This is an exploded view of how it could look. Of course, this panel will have to be, cut in half. It all depends on transport options. Where are you going to do it? Prefabricated. It's going to be on site. It's going to be off site, and then these are considerations, of course, to address. Just a quick image to show how it could be craned into place, but you can see that crane is just not being used. A slight mistake there, but look, it gives an idea. And then, of course, it's an architectural consideration to have. Prefabrication is all well and good. You have pre-finished products, factory settings. It's fantastic. We architects love it, but you have to consider the joints and all the rest. So if you design it with that kind of prefabrication in mind, it's good to do it at a very early design stage. So we sent all our files to Solibri to check for model integrity. We had actually a workshop, very successful actually a few days ago with the whole team. We're all there learning about how to do code compliance checking, and they had a look at our model. And of course, we were involved in the model, the making of the architectural model, and they came up with some issues like classification issues that may not have been correct. There were also some issues with some stairs, small stairs in some areas. But anyway, there were all minor issues. And we have to say that it's a very quick demonstration of the code compliance checking. And I think that's hugely relevant, especially now with the new regulations coming into force, where you can check for compliance with Part M or any other building regulations that could be automated quite easily in the office using Solibri, or I'm sure there are other tools as well. There's another issue there. It's like a file, the M&E file, actually. They notified us that it's slightly in mid-air, slightly too high above the building. And indeed, when we assembled the building, it was 80 meters, offset. We could fix it in TechLab, but it's very important, and that should be part of the kind of the BIM implementation plan, that everybody issues, proper files with proper project origins. So now I'm going to hand over to Paul, which will speak about Nugent Manufacturing input. Thank you.
Great. I've been asked to speak on behalf of Pearson Van and Nugent Manufacturing, and just through to their workload. Just a little bit first about Nugent. Nugent have been was founded in 1999 to manufacture structural steel, secondary steelwork, balconies, fires, escapes, a whole range of steel structure. And they started with 3 employees and grew to over 4 million a year, and over 30 employees. And they've done work for on the Viva Stadium, Microsoft DBs, and also work in Diageo at the moment. If you're down past St James's Gate, you see the steelwork there. That's them. This is also a structure they did in 2011. It was their Chelsea Flower Show. They did the steel fabrication work for Dermot Gavin and his gold medal win there. Pearson Van is actually, his background is as a apprentice structural fabricator, so a structural fabricator who's moved into detail, and I think that's just, it really is great. You have someone who's able to model, but also has an appreciation of real life and what you have to do. So the pilot model, we got such a huge amount of data, it's impossible to present it all here, and then a huge amount of files. But this is, again, you've seen some of these before. These are the type of outputs, full schedule of all parts and pieces that would have come with the model. And then this is an example just of the stairs to the side, where it's broken down to pieces. And if you just look at the very key element, to look at the health and safety aspects of if particularly with manual handling, how heavy particular pieces are going to go, and how you're going to crew that, not just with craneage. So again, typical fabrication drawings, pretty much spitting straight out of the model, and annotated straight out of the model, to result in the numerical control files for the CNC machines. So these are DSTV standard, which is a German steel construction association standard that they created. But to look at it, I kind of like these kind of formats because it really is very simple, and to emphasize the size of the point, it's like binary for computers, that it's very, very simple. For machine manufacturer, they need a very, very simple format. So while on the face of it, all these technologies are very graphic, 3D, and it looks great, at the bottom line, this is the kind of real stuff that you want. So just taking the stairs, for example, that's a Tekla export. I've been using Tekla since about 2004, version 11, and it would have been usual in that respect, I think, in Ireland. But this is a Tekla export to IFC, just of the stairs, to show basically the quality of the output. Again, different aspects, all the information that's associated with different aspects. We have the bolts switched on in this case. Again, some of the steel framing around the single-story podium at the time. The pilot project, unfortunately, from a structural point of view, wasn't really too exciting, because there wasn't really that much to it. But I think we're hoping, at least we're hoping that it will show some of the principles involved. This is a two-story section to the front, and we've used some, Pearson's used some purlins, and that'll become relevant in the middle. So taking that to Tekla BIM site, and this is the structural model in Tekla BIM site. So we had some, you would have seen this the last time we presented, with some precast units on some basic steel framing, and integrating the Tekla model over it. You'll see straight away that I didn't appreciate this straight off, but you can see there's been a bit of the Tekla file, the IFC file, was modified by the detailers to make the detailing process much more efficient. So that has that's the Tekla model switched on, and you can see that has an impact. So when a change is made, there's an impact on other trades. So the precast slabs that we had, if the precast units and the structural steelwork were all integrated and associated, well, that maybe would have happened, but then who has control of all that? So this was all part of a back and forth, and obviously some of my slab detailing was a bit too over enthusiastic there. So looking at the front section, again, this is the input from Piers. And you can see, okay, he's chosen to use some purlins. We had a timber frame structure for different, because it's just a pretty small section of roof. In these type of projects, because of the scale is so small, you're nearly in a halfway point about what's the best kind of structural solution, or what kind of builder maybe is going to be using it. So again, like the high level of detail, again, we have the bolts it's switched off in this. And again, you can see really up close on personal with the model, and there's no end of shots. We said before that a picture picture speaks 1,000 words. A BIM model is effectively 1,000 pictures. So this is the highlighted section is actually the stairs object that would have been modelled originally in the original authoring tool, and then that's overlaid with the Tekla model. And again, you can see the quality detail. I'm a member of the I/D, and I'm the I/D representative to CITA, and so I'd be remiss not to just highlight that there's a document there that we've had since 2002 about the use of computers in engineering calculations, and particularly with respect to some failures that have happened because of maybe the garbage in, garbage out. So with all modelling, it's all about validation and verification of the model, and whether that's model for fabrication or model for design or analysis. I will say one thing about IFC. My experience of IFC has been actually very good. I haven't had too many issues, but I have seen issues like this, and if anyone has looked at maybe IFC, they might have come across this type of thing where you can see obviously this is rubbish, but you get translation issues sometimes. There's 355 meters, the floor slabs are over here from here. So, but for me, I don't see this is a problem. I just see that it's about communication, and communication is a two-way thing. If you're going to pass information to someone, you have to give it to them in a format that they can interpret properly. Otherwise, you're effectively just dumping on them. And lastly, I'd say that the reason I talk a lot about issues with the quality and the veracity of information. This is a famous, I suppose, description of structural engineering by an anonymous author. Well, but it's really about, it's real life is different. Computer software can make everything seem to be perfect, and that's why the experience of the steel industry and also the precast industry, and also with the likes of Kingspan, are really I think are really showing the way of what we need to be need to be doing. But we need to kind of keep it real. So I'm just going to pass on to Keith now again, and he'll just finishing up for us.
Thank you. So I'll just quickly run through some of the steps that we've taken. Now, just in terms of the time we've had with this, it probably only came to us about 2 weeks ago, and we only had a day or less than a day to spend on it. But what we did was to look at the pilot model and selectively pick a few parts of the model to apply some Kingspan product to. Now, I think we've got a combination of roof and wall panels as well as some of the benchmark create system we spoke about earlier. So I guess really in terms of the major steps, we imported the IFC model into Tekla Structures. The name we refer to that package as internally as KingCAD. It's our sort of extended version of Tekla Structures, so it has a lot of our macros and plugins in there, but they're reference objects or files only really at that stage. There was a filtering out of any obstructive or irrelevant surfaces just to allow you to see what you need to see to apply the Kingspan product to the building. 2D elevations and plan views, and then we're into the setting out of the Kingspan roof and wall sheeting planes, checking for squareness and class issues. An example of an issue, and we've got a few here, and I guess these may be as a consequence of the fact that it's a pilot project and everyone's kind of faced with time constraints, but we do see this sort of stuff in the real world as well, and it kind of links back to the question that was asked earlier. Is it a cultural issue? Is it a real issue? I think it's both, to be fair, and it should improve over time as people evolve and start to get to grips with what's required. But you can see here we had the modelled wall protruding through the roof plane, so obviously there's something there to be rectified by the designers. Issues with the set-outs not being perpendicular, so you can see, I think, on the next slide as well, we've got issues here with the purlings not being lined up as well. So there's just a number of things which were needing to be corrected on the fly. Now, I guess in a collaborative scenario, you'd probably be doing the two-way thing and asking the owner of the model to correct those errors so that you then can continue, but we just took the view that for expediency would just make the corrections and kind of get on with it really. So again, it's really just sort of snapshots of the stages we've gone through. Now this is really one of the many plugins that we have to the Tekla system, and you can see you've got a floating toolbar sitting above the main Tekla Structures application. A lot of tabs on there which then have numerous parameters, drop-down menus, etc. They're parametric, they're working in a very similar way to our SAP system, so it's variant configuration. If you choose a value for option A, that will then drive the next menu choices based on valid configuration, so it's applying business rules, engineering rules, etc. So we can then sheet a roof and add roof lights in and gutters and flashings and stuff like that. Ultimately it'll produce the bill of materials or the material list that we were seeing earlier, and that can be uploaded either for quotation purposes or for sales order entry and then production orders, and then later still onto the production line side, the CAD-CAM end of things. So again, you can just sort of see tidying up of some of the components that are being added. So just making it, I guess, cosmetically accurate. I guess some of this stuff would be cut on site, so if you were to leave the model looking like it would be in the real world in terms of how long the products would be, you'd have things sticking off the end and stuff, and that might not look right for the design team or the client. So Martin, who did the modelling here, would tend to just go and clean it up, even though that would be cut on site, just to make it look right in the model itself. So again, you can see just the various stages of applying the products. Again, more bespoke tool sets and macros here for flashings, etc. And I'll skip forwards now. You can see the create system coming in, and this sort of elevation now that's on screen. It's a very simplistic version of what create is, but it's just to show that you can have a unique configuration of panels and cassettes on a wall, different colours, finishes, etc. to achieve an overall design aim. And that would then be kind of prefabricated, so it's something we can do. And I guess the challenge for IT is that, and Kingspan as a business, is that obviously people want to push the envelope in terms of design, and that then leads to increased sophistication in the manufacturing process. Now, I think we can cope with that from a technology perspective, but we need to be given accurate information up front, really, and early involvement I think is key. At the back end of this, then obviously we're exporting the IFC model back to allow it to be included in the federated model, so that you can turn it on and off in BIM site and see the Kingspan products that we've applied. And I think there was this was just checking the model origin, I guess, so that the different IFC models that align to one another. So that's pretty much what we did in a very shortened version.
Brilliant.
Thank you.
That's it.
Are you finished, Bernard?
Yes, well, we're almost finished. It's just to say that next month we'll have another session at this, and we'll be discussing
That's the last one.
the last one, so don't miss it. Because we'll have the lessons learned, what to do, what not, what not to do, of course. We have a very interesting 4D simulation that is in the work at the moment. It's being prepared by PPM, and we'll have a BIM for FM, and then also an extended Q&A session. And the whole thing will also be presented at the BIM gathering in November, so I'll really encourage you to attend that as well. So it's going to be a very exciting lineup of speakers.